This learning object is a production of Abu Dhabi Men's College, Center of Excellence for ICT and Learning Technology.
In civil engineering, all the construction materials have different properties. These properties are very important for a civil engineer. One of the most important properties is the density. And we can identify the density of the different construction materials. It can be concrete or wood or glass or steel. We have one interesting construction material, and this is the soil. The soil is an interesting material because it's not man-made. We have to deal with the soil as it was created by the nature. Our soils, what we have to deal on the construction site, all these soils are coming from different types of rocks. Once the rocks are breaking up, the larger rocks are breaking up to smaller pieces, and then we have different sizes, and if the size is different, we have different names for those soils. We have a table here that show the different types of soils, and I will just stick to three soils here which are the most representative in the UAE. And these three soils are the gravel, the sand, and the silt. These three soils are granular soils because they include small grains. I take one grain from here, and all these grains are coming from different types of rocks. When the grain size is between 2 millimeters and 60 millimeters, we call the soil gravel. If the size of the grain is smaller than 2 millimeters, we call it sand, and if it is smaller than 0.06 millimeter, that is the silt. These soils, of course, on a construction site, we can have not only one soil, not only sand or silt or gravel, but generally we have a mix of these soils. We can have a soil when we have only one fraction, let's say just sand, like we have in the desert. Then we have poorly graded. We can see that it includes only one grains. If we have two components in a mix, then we can call it gap-graded soil or well-graded soil. Now we know from engineering practice that the density of the construction materials can be identified by the mass divided by the volume. Now we can see here that for soil, the most important component of the soil is the solid grain that is coming from the rock. Between those grains, we have airspace. We have void in the soil. The ratio between the volume of the void and the volume of the solid is a very important soil property. This is called the void ratio. The void ratio of the soil, again, I have one drawing that represents the two components. We have the solid grains, and then we have the voids here. We call the voids together porosity. In the voids in the soil, generally we can have air or we can have water. Sometimes we have only air in a dry soil, or we have only water in a saturated soil, or we can have both in certain situations. Irrespective of what we have in the void, the most important component is the solid. How much solid do I have in the soil? The higher percentage of solid gives me a much stronger soil. If I have a soil when the percentage of the solid is smaller, then I have a looser soil which is not as strong, and I have to decide, can I build a building on that soil without any potential problems or not? The ratio, again, between the porosity and the solid phase is called the void ratio. Generally, if I take a look in these soils, the ratio between the voids and the solid phase is 50-50%. If you walk in the soil, let's say in the desert, you can't imagine, but half of the volume in a unit volume of soil is actually airspace. So 50%, 50%. When I have a mix of soils, I can have different void ratios because I can have in certain soil a higher percentage of porosity or a lower percentage of porosity. How much is the porosity in a soil is depending on the shape of the soil grains and on the ratio between the different fractions. we can see that if I have a poorly graded soil, it means I have a higher percentage of air space within the soils, then I have a higher void ratio of the soil, because again the void ratio is the ratio between the void to the solid phase. On the other hand, if I have a well-graded soil, we can see that the smaller grains can fit into the space between the larger grains, and in this case I have much more solid phase inside a certain volume of soil. We can see if I want to build anything on that type of soil, I will have less chance to any potential problem like settlement under the building, or if I would build on a soil which is poorly graded. How can I identify in the soil that what is the maximum void ratio or the minimum void ratio? For that, I have to do two very simple tests. Again, I come back to these three drawings. These three drawings are representing the two extreme situations when I have maximum porosity and minimum porosity. These situations can be identified in a lab. I have to bring in the soil sample from the construction site, and I carry out two tests to identify the maximum void ratio and the minimum void ratio. What do I do to identify the maximum? I take a cylinder, because I have to know the volume of the soil to identify the density, and from the density to the amount of porosity. I just take the dry soil and I just pour it into a cylinder. When I finish that, I have a certain volume for the soil sample. I can identify the dry mass of the solid phase inside the soil, and from the ratio I identify the dry density of the soil, and from there I calculate the void ratio, the maximum porosity, and with that the maximum void ratio of the soil. For every soil it has a maximum void ratio. If I have a poorly graded soil, possibly this is a very high percentage, I have a high maximum void ratio, or if I have a well-graded soil, then maybe this is a little bit less. So the maximum void ratio is actually a little bit higher, or a little bit lower number. The other extreme situation is when I have to create a soil sample where I will have the potentially smallest voids inside the soil. A condition when I have maximum solid component in a soil sample. It means I have to decrease the amount of porosity in the soil sample. For that, I have to carry out the so-called Proctor compaction test. For that test, I will use a larger cylinder, because I will have to use more soil, and we have a certain size of hammer to compact the soil into the cylinder. The size of the hammer and the size of the cylinder is a standard in every single country in the world.